Today we are discussing with the new types of problem for SFD BMD. This is actually look like statically indeterminate. So what is statically determinate or indeterminate? The beam which we solved by the equilibrium equation, that is statically determinate, where equilibrium equation is summation of vertical force equal to 0, summation of moment any point equal to 0, summation of horizontal force equal to 0. This is the equilibrium equation. So if the reaction leave the unknown equal to 3 or less, then that is called statically determinate. Where the reaction unknown is more than 3, then that structure is statically indeterminate. So look at this structure here. This point vertical force and horizontal force exist there. This is only vertical force RC, here RB vertical and RB horizontal. Two types of reaction exist, and this is also two types reaction, RA vertical, RA horizontal. So total reaction unknown 1, 2, 3, 4, 5, more than 3. So this is actually statically indeterminate. So we cannot solve statically indeterminate structure by our general calculation, our general system. So for solving this, there are two conditions. One is E equal to minus 16k shear at E. This point shear is given, and another condition is hinge at D. That means this point is hinge point. So if two condition, 3 equation plus 2 condition, so total 5, and our unknown is 22415. So now this structure will be statically determinate. So what is hinge at D? So hinge point D like this. This actually hinge this point like this now, and actually we know that hinge point like this type. So here only one types of load are passing, or this direction or this direction. So this type of hinge, we can see that only vertical force are transmitted to this, so no horizontal force are transmitted by this, because this point cannot take any horizontal force or moving force. So if the D point like this, no horizontal force here, then there is no horizontal force, so RAB equal to 0, because there is no, as this point doesn't carry any horizontal force and there is no horizontal force, so RA horizontal equal to 0. Another is for E, shear at E minus 16. So if we draw SFD for E point like this point something, here is 16, so this area whole 16 keep negative. So if we term this point force, there is 60 kept downward, So this is 16 kip, here is 16 kip. So this is small from this 16 kip, so obviously there is some shear, upward shear, positive shear, because this positive shear going to minus 16 negative for this 60. So the difference is 60 minus 16, 60 minus 16 equal to 44. So here the horizontal force, shear force is 44 kip, which is positive. So look at this, here is this 44 kip upward, positive 44 kip means here is upward force of positive this point. So this upward force is coming from RA vertical, because there is no other force here or inclined or other force, so direct go to RA vertical, which is equal to 44 kip upward. So look at this, upward 44 kip going to this, and minus 16 kip downward, 16 kip difference, minus 16 kip here, and here is also minus 16 kip, and here we see the 60 kip downward. So both are negative, minus 16 minus 60 going to 76, minus 76. Now this point, now we have to determine RA vertical for this area. So for now we have three unknown, RAV, RV horizontal, and RC. For this we should take moment at B. So for moment at B we can calculate here, summation of moment of B equal to 0, clockwise positive. So what is our force? 44, 44, this is 10, 10, 20, 28, this is clockwise, 44 into 28, and now this force, this is anti-clockwise, this is anti-clockwise, this is anti-clockwise, both. This is working as 10 plus 8, 18 feet distance, and this is only 8 feet distance, both are negative. So minus 60 into 18 minus 60 into 8. So there all forces are calculated, so and there is no other force. So this distributed 8 keys, this is clockwise positive, 8 key, it is acting through this 30 feet, so plus 8 feet into 30, and this is working middle of this, from middle of this 30, this, that means 30 divided by 2, and RC also anti-clockwise, so minus RC into, this is working 30, 30, and now this 20, 20 acting 6 plus 16, clockwise 6 plus 16, so plus 20 into 6 plus 16 equal to 0. Now we get RC equal to, calculating this, so RC is, we can here get 123.73 grip, so this is equal to 123.73 grip. Now the horizontal force, so look at here, there is only one horizontal force 20, because there is no horizontal force existing, this point is hinge, so 20 keep. So RB horizontal equal to 20 keep. So we required only RB vertical. So vertical force, we can calculate summation of vertical force. The summation of vertical force upward positive, so downward upward positive 44 plus minus 60 minus 60. This is RB vertical positive. As we can denote here, summation of vertical force equal to 0 upward positive 44, this 44 positive, 60 negative, minus 60 minus 60. RB vertical, this is positive, RB vertical, this is negative. 8 into 30 minus 8 into 30, and here this is positive, plus 123.73 equal to 0. RB vertical equal to, get, so by calculating this we get RB vertical equal to 192.27 keep, so equal to 192.27 keep. Now we get all of our unknown, so we can draw our SFD BMD. So first of all, we'll look at here. There is no horizontal force, RA horizontal equal to 0, there is no other force equal to 0, so SFD like 0. And for vertical force, there is no moment 0, there is no moment 0, full area is 0. This is BMD, both are 0, which is, this is keep fit, this is keep. Now we go through for this SFD we already draw for this section. Now go for this section. For this section, this point minus 76, so we minus 76. Now this is upward, RB vertical positive 192.27, so positive 192.27 equal to 116.27 positive, so upward 116.27. Now for this is distributed load, so downward negative 8 into 30 minus 8 into 30 equal to 123.73 minus, so this point like 123.7 123.73. So this is inclined because this is distributed load, inclined, like we draw it like not straight. Second degree, sorry, this first degree, second degree, sorry. So this is straight inclined. Now minus 123.73, and this is upward 123.73, so this is, here is 0, and this is straight to the, there is no force available here, so this is also 0. So this is our SFD for, this is negative, this is positive. So we calculate this distance by which 116.27 decreases to 0 by 8 for this. So that if we 116.27 divided by 8, 14.53, so this distance is 14.53 feet, and this distance also we get by minus from this 30, minus 30, 15.46, which is 47. We noted it because this is 53, so this is 47, 15.47 distance of here. This is required for our moment calculation by area method. So now for this force SFD, first we calculate SFD for this. So there is 20 upward, 20 keep upward, so there is no other force, so direct 20 go to this point straight, positive 20. So here 20 is no other force, so if we get free body, there is 20 downward like this, here is some 20 which is also affected by this. For this 20 keep going to this 0, here we introduce some force. If we make a free body, there is this type of 20 keep this way, and this is balanced by another 20 keep this way, and this 20 and this 20 are balanced by 0, and this 20 reduced by this for this area. So if we introduce a 20 keep here and introduce this direction 20 keep here, so this 20 keep is 0 is reduced by this, and here another 20 keep is upward 20, and this is going to throw direct this way, and this 20 is going to 0 by this 20 keep balance. So this is our diagram. Actually here only force 20 keep, and this 20 keep is transmit by this way, this 20 this is, and this is come to here and balanced by this 20 keep, and this 20 keep is balanced by this 20 keep, and this is also balanced by this 20 keep. Here is the free body diagram of like this: 20 keep, 20 keep, 20 keep, 20 keep. The force is like this. Here is this direction both are same force equal to 0, and this going to this. So this is SFD, this is SFD, this is keep, this is keep. So we calculate our all of SFD. Now we going to our BMD. This BMD is already drawn. Now this BMD, for this there is no moment, so it is start from here 0 because there is no moment. So by we can calculate this area method. Here is area 44 into 10, 44 into 10 positive, we get 440. This is like this, 440. Now for this area, there is 16 key and the distance is 10 feet, which is negative. So minus, negative means minus this 16 key and distance is 10, 280. This is also positive, 280. Now this area negative 76 kip and distance is 8 feet, so negative minus 76 to 8 minus 380 is like this 328, sorry, not 18, this is 328. This is 28. And now here is the moment junction. So moment, so we get minus 328. That means this is like minus 328 like this. This is acting to this way and this is balanced by this moment, this direction. So and now we get to this member. If we get to this member, so here is also 0 and 20 keep positive, so the moment is also here positive. Moment is like this, 20 into distance is 16, so 16, this is 320 positive. Positive means this is actually like inclined this way. 320 moment is also positive. So this 320 acting like which way? Positive. Positive means this way. So we can saw the moment positive and negative. Which is positive? If this is the beam, if moment acting like this way and this way, this is positive. And if the moment acting like this way and this way, this is negative, because this type of moment tends to this beam like this and this type of moment tends to like beam like this. So this is positive and this is acting like this way of this member. So this is balanced by this opposite direction of moment. So for point this moment and this moment is actually opposite, which is this moment is 328 and this moment is 320. So actually for balancing, this way 328, this way 320. So for balancing we required this type of another moment, same direction of this. So this is 328, 320, that means 8 is, if we get 8, then 8 plus 320, 328, and balanced by this 328, okay, equal to 0. So this moment is balanced by also this for this area. So this is also negative 8. So for this member the moment is only 8 for this. So this 328 is balanced by minus 8 only for this member. So this 8, now there is positive, so we have minus 8 moment and positive. This is a triangle, here is base, height, so positive plus for area of triangle half into base 14.53 into height 116.27, this is 836.7 positive, 836.7. so this is a curve because there is distributed. Now the negative triangle, so minus half into base is 15.47 into height is 123.73, there is minus 120.53. So this is 120.35. This is also like curve. This is also curve. Now here is there is no shear force, so this is going directly through this 120.35 for this point. Now this 120 is negative, so this is going to for this area. This is negative. Negative means for this area actually like this is negative like this, and this is balanced by this, and for this member this is counterbalanced by this, and also this is for this direction it is balanced by this. So actually balancing the moment like this coming from our this negative value, and this is balanced by this for this member, and also for this member transmission of this moment to this moment, this is counterbalanced by this, and this moment also balanced by here for this member. So this is negative also. Negative means (120.35) minus. So minus 120.35 here also minus. Now this is shear force is 20 into distance is 6. So then this is plus 20 into 6 equal to this is slide for the fraction result. Assume here it is as like 0. So this is for BMD. This is also BMD of this member, and this is the BMD so this is our SFD and BMD diagram of this structure.